Right, okay, so in the next part, we're going to be looking at different types of integrals. So, what happens if we have something of the form which is ax plus b to the power of n? So, this is things we were dealing with maybe in weeks 2 or 3, and it might not always be straightforward when we're doing our integration. So, but what we can do is we can do something called substitution. So, say for example, our exam question would be integrate 2x plus 3 with respect to x, and it's going to be to the power of 4. So, what we can say first of all is we've got two kind of parts of the equation here, and we're going to simplify it, and we're going to call this u. So u equals 2x plus 3. So this means that our equation now becomes the integral of u to the power of 4 respect to x. This seems to be quite simple. But okay, well, that's not all right because we have a u here now and we don't actually have a a du which we need to be integrating with respect to u. So what we can say is if we have u here and we differentiate this, we can then say, well, du by dx equals 2x plus, equals 2. And this is just by doing our differentiation. So again, to differentiate, you've got to be slide, bring the power down, multiply, be really cool, get the job done, reduce the power by a factor of 1. And what we've found is our du by dx equals 2. This is quite neat now because what we can actually say is we want to have a du here and not a dx. So we can say, well, du has to, dx has to equal du divided by 2. Great. So we now have a way in which we can get du back into this equation. So we can say our integral of u to the power 4 dx, well, we've got dx, we can sub this in, which is du over 2, or we can then pull this out to say a half our integral of u to the power 4 du. We now have a means in which we can integrate this u to the power of 4. So therefore, what we can say is, well, we can we can we can we can integrate our value where we have a half outside of the bracket, u to the 4 du. So what this is we add 1 to the power and divide by the new power. So that would be a half multiplied by u to the power of 5 divided by 5. And then all we have to do is sub in our original values for u. Therefore, our answer would go to, when we get our u back, 1 divided by 10, because we have a multiplier, we have a 5 and a 2. Open brackets, our u, which is 2x plus 3. And then we have our 5, which we've just calculated, and that would be our final answer. So we could say that the the integral of 2x plus 3 to the power of 4 with respect to x is equal to 1 over 10 2x plus 3 to the power of 5. So what we've actually done here again is we've recreated some sort of relationship which you might want to remember for the exam, or you can work through it as we've just seen, where ax plus b to the power of n with respect to dx is equal to 1 over a n plus 1 ax plus b n plus 1 plus c. Quite a complicated thing to remember. Personally, if I was to do this in the exam, I would work through the example like we've just seen. Okay, so that was actually just a different type of integration. Now we're going to look at something called